Alright, so today we're going to be talking a little bit about a topic that we've covered in the past, and that topic, you can go ahead and write this down in your notebook, it's going to be number 26. It's going to be number 26. And we're going to call this solving exponential inequalities. All right, solving exponential inequalities. And when we're working with these, we're actually going to be reverting back to some things we've already talked about in this unit, and then some things we also talked about in the linear unit we already covered. So the first thing I want to do is I want to go through a simple problem, and let's just look at this and see how we would solve it. So first problem I want to look at is 5 to the 2x power is equal to 1, let's do 625. So we're going to do 5 to the 2x power is equal to 625. Now, we know with a problem like this, the way we would solve it is we would have to get the bases to be equal to 5. So since this base is already equal to 5, we just rewrite it as 5 to the 2x power. But on the other side, we've got to think about how 525 can change into a different number. So with this, we would be thinking about the powers of 5. So we know that 625 is going to be 5 times 5, which is 25, times 5, which would be 125, and then times 5, which would be 625. So if we count those, we've got 1, 2, 3, 4, 5s, which means that we can rewrite this as 5 to the 4th power. Now, once we've got 5 to the 4th power, and we can see that our bases, our 5s are the same, we can then take and drop the 5s, and we can bring down our exponents, and we're going to get 2x is equal to 4. To finish out solving this, we would just take and divide both sides by 2. 2's would cancel out, and we would get x equals 4. Or x equals 2, sorry. Now, what we're going to be working with today is very similar to this. The only difference is we're going to be using inequalities. So let's look at it. Let's just take the same example and look at it a different way with an inequality rather than an equal sign. So we'll do it side by side. All right, so in this problem, let's go ahead and see if we can work it out the exact same way, the exact same problem, just with an inequality. So let's still do 5 to the 2x power is greater than or equal to 625. So if I wanted to work this problem out, I know that I would still do the same thing, right? I would take, this would be 5 to the 2x power is greater than or equal to, and then 625 I know would change to 5 to the 4th power. From here, I could drop the 5s on both sides, and I would get 2x is greater than or equal to 4. Then I could divide both sides by 2, and I would get x is greater than or equal to 2. So if you notice, really we don't do anything crazy here. Everything's exactly the same. On one side we have equals, on the other side we have a greater than or equal to. The steps, the process is all still the same. The only difference is how we get to our answer, or when we get to our answer, we may have a different sign in the middle. Now, if you run across a problem that has a sign like this, sometimes it's going to ask you to solve, and then other times it's going to ask you to graph. So let's look at another example and discuss how we would graph this. Alright, so in another example, we can be dealing with some of the similar situation or the same scenario, but when we want to graph it on a number line, it's actually going to go back to something we talked about in the linear unit. So let's just look at one problem real quick, and then we'll work one more problem to be finished. Alright, so let's look at the problem. Let's say we have the problem, let's go with 2 to the, let's go with 2 to the 2x power, or let's do negative 2x power. So 2 to the negative 2x power And let's do minus 2 equals 30, because this one's giving some people some fits today. Now, anytime that we run across a problem like this, what we've got to do is we've got to first get rid of our subtraction. So to get rid of subtraction, we know the inverse is what? Addition. So we're going to add 2 to both sides. We'll get the 2's to cancel out, and that's going to be 2 to the negative 2x power is equal to 32. Now we can start changing some bases around. So with 32, we want to think about that as 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and then 16 times 2 is 32. So that's going to be 1, 2, 3, 4, 5 2's. So we're going to rewrite this as 2 to the negative 2x power is equal to, and then here we're going to do 2 to the 5th power. Real quick, let's go back and change something. I meant to change this. Let's change this to, we want to shrink this eraser down so we don't erase a bunch of stuff. Let's change these equal signs into inequalities. I didn't mean to do that. I completely forgot. All right. So back to this problem. So let's say we had, let's just go with greater than. So on this one we would have greater than, here we would have greater than. All right, back to our problem. So we got our bases to be the same. We know they're both 2. So from here we know we can drop our 2's. And then to solve the rest of the problem, we would go negative 2x is greater than 5. So when we divide by a negative 2, what happens to the inequality sign when we divide by a negative number? We flip it. So that's going to be x is less than, and then 5 divided by negative 2 is going to give us a decimal of negative 2.5 or negative 2.5. So kind of the same properties apply. We still have to switch the sign when we divide by a negative. Now, on the number line, we're going to have kind of a similar situation. If you recall, we talked a little while ago about open circles and closed circles. And we said that open circles is going to be when we have less than or greater than. And then solid circles or closed circles are going to be when we have less than or equal to or greater than or equal to. So on this specific number line, we're dealing with the number negative 2.5. So we can go ahead and label out some numbers. Since we're dealing with negative 2.5, let's go with negative 4, negative 3, negative 2, negative 1, and 0. So if we want to graph this, we want to take and go over the number negative 2.5. So we're going to come out here and go over the number negative 2, and then negative 2.5 is going to be halfway between negative 2 and negative 3. So above that, we're going to have, in this case with the sign, we're going to have an open circle. And then since this sign says less than, we know all the values that are less than are to the left. So that would have been how we would have graphed this. And if you want to get technical with it, you can go in and put in the negative 2.5 if that makes you feel better so that you're representing that point. But as long as you mark it on the number line and you have it have the answer written out beside it, you should be okay. But for some of you guys, you may want to go back and put that number in beside it whenever you do the problem. All right, so our next problem we're going to look at, let's do the problem, I'm trying to make this one up off my head. Let's do 25 times, and then we'll do 125, and let's do 125 to the negative x power is greater than or less than or equal to 625. All right, so real quick, go ahead and pause the video and you can go over and see if you can work this problem. And then when you're ready to continue, you may go ahead and continue. All right, so going back to our problem, what we're going to do in this problem is first we got to break these down. So with 25, we know 25 will break down into 5 times 5. So that's going to be 5 squared. Now, with 125, we're going to break it down into 5 times 5, which is 25, times 5, which is going to be 125. So in that one, we're going to have 5 to the 3rd power. But we've also got that other power, which means we've got to multiply it times negative x. Then we have less than or equal to 625. Now 625 is going to be 5 times 5 times 5 times 5. Because 5 times 5 is 25, 25 times 5 is 125, 125 times 5 is 625. So in this one, we've got 5 to the 4th power. Now, with the multiplication, now this is a little bit different from the subtraction. With multiplication, we have to add the exponents. So when we add our exponents, that's going to be 2 plus 3 times negative x, which is negative 3x. So that's going to be 2 plus negative 3x. And then we're going to have less than or equal to 5 to the 4th power. From here, we can drop our 5s. And we're going to have 2 plus negative 3, or you can just write 2 minus 3x. 2 plus negative 3x is less than or equal to 4. So subtract 2 from both sides. The rest of it's a two-step equation. And we're going to have negative 3x is less than or equal to 2. Divide by negative 3 on both sides. Negative 3's cancel out. And we're going to end up with an answer of x is greater than or equal to, because we divide by negative. And then 2 divided by negative 3 is going to be negative 2/3. So we got a little bit different of a fraction on this one when we simplified it and solved it for the answer. Now, if it asks for us to put it in the number line, we could draw a number line. We know that negative 2/3 is going to come between 0 and negative 1, so we need negative 2, negative 1, 0, and 1. You can do 2 if you want to. Here we have negative 2/3, so negative 2/3 is going to come out about there. And like I said, you can guess at it. Just make sure you label it. That way the person looking at it would know. And then with this one, we've got greater than or equal to, meaning that it's going to be a solid dot. And then when x is greater than, that means all the values are going to be shaded to the right. So with these problems, you're not going to run into a whole lot of different stuff. It's mostly things that we've done in the past, especially with the solving part. We've talked about that this past week and went over how to do that, but now we're just adding the inequalities. And then when we add an inequality, all that really changes is sometimes we're going to have to make a number line. And we've talked about number lines in the last unit and how to create those. As long as you know that it's a solid dot whenever it's equal to, and it's an open dot when it's not equal to, you'll be all right. Okay. So if you have any questions, feel free to ask me. Just let me know and I'll answer your questions. Otherwise, you can go ahead and begin working on our work for the day.